Mr. Gologan, the stage is yours. Title of your presentation today, Pioneering Electric Aviation in 10 years from Elektra One to the Scylax E10. Please go ahead.
Yes, hello. Thank you for the invitation. I'm happy to be here again at the AERO after many years of stops, and to enjoy at first the spirit from AERO, because here is a real spirit of aviation, especially for new technologies. This presentation was done also together with Konstantin Kondak, who cannot is the second CEO of our company. And now we start. So what we want to do at the end, we want to go up to the level of regional mobility. But for this, we need a basic technology. And we need to start on a lower level and then step by step go to commercial aviation. So now I present you a little of our history. We were here for the first time at the AERO 2010 with the mock-up of Elektra One, and this time we did many developments, and we are so far now and in the future to go to regional mobility. You see here are some of our products: Elektra One, Elektra Solar, Elektra Solar UAS, who are unmanned, and Elektra Trainer, and later Elektra 10. So from the history, introduction was done before. So we are a spin-off from DRR, Institute for Robotics and Mechatronics. We did the first flight Elektra One in 2011. 2015 we flew over the Alps with Elektra One. 2016 we flew for the first time with Elektra Solar, Solar Stratos in Switzerland. Then 2019 we did an unmanned flight with the unmanned version of Elektra Solar, 10 kilometers, including start and landing, only with the energy of the battery and the sun. And 2021 we certified last year Elektra One in the German ultralight category, LTF-UL, the new version 2020. And now, during this era, we present for the first time our two-seat trainer, Elektra Trainer. I name it the vision of our company, from evolution to revolution. Evolution, of course, electric flight is an evolution. We fly emission-free. We want to be emission-free in CO2, but also in noise is on the same level, very important. We want to reduce operation costs in all our products to have a simple logistic. And one important thing is energy efficiency. Energy efficiency is the first condition for the future of electric aviation. One characteristic of our company, the whole IP, from the structure, aerodynamic, up to the whole electric power unit system, solar system, is internal technology and autopilot. We have half of the team is electric, electronic, half structure. And here, as design philosophy is a family philosophy. All our products are looking similar from the aerodynamic point of view and use the same systems. This reduces, of course, a lot our investment in development. All our products are looking similar, and that's why we could, in a short time, develop new products. Elektra One, you see here a picture, you can look here, is certified in the German ultralight class. What is here amazing is that the aircraft is flying at 300-meter altitude. You don't hear. The RPM of a propeller is very low, and this is a very important condition. We fly with 1,500 RPM, and the noise level is only 55 decibel. Now, Elektra Trainer is a new product you can see in hall A7. What is our main goal? Is zero emission, very low noise, of course, 55 decibel, and low operation cost. Another important thing for us is to have a good comfort, easy logistic to assemble the aircraft in a half an hour from the trailer. We have a portable charging system you can put in a big baggage compartment. So we fulfill in this way the most of the needs of, for a training for flying schools and the flying clubs. You see? And it can be used in a training cycle where we fly 50 minutes. In 30 minutes, we can charge it a little, and it's flying only with 12 kilowatt. We don't overload the battery. That's why the battery may be used for about 1,000 cycles, and we reduce the operation cost of the electric power unit. That is important. Data sheet is a low-speed aircraft, can fly 2.5 hours, about 300 kilometers, and with a low limit speed in the German ultralight class. Another aircraft we developed is Elektra Solar, is 25 up to 27 meter. Is flying, one of these is flying in Switzerland as a Solar Stratos project with a goal to fly in the stratospheric in the next 2 years. The project initiated by Raphael Donjan. You see here, last year was the first jump with a parachute from an electric solar aircraft in Switzerland. It was a nice event. And then Elektra Solar UAS is an unmanned version. With this aircraft, we produced 2 of them. We flew 2019 to a 10-kilometer altitude, completely unmanned start and landing with our own autopilot system. And now, based on this technology, which we developed in the last 10, 11 years, we are so far to go in direction regional mobility. And this cannot be done from zero. We need this basic technology developed in all this company you see at the AERO. Only based on this technology, long technology, we discovered a lot of good things, wrong things, we improved. We did also for a lot of mistakes. But now, based on this technology, we developed a new concept for regional mobility inside the Scylax company, where Elektra Solar is the main shareholder. It's the product E10, a 10-seat aircraft for regional mobility. What is characteristic for this aircraft? In the design, which was done with our future customer, we discussed which must be the main characteristic. It's a stalled aircraft. This aircraft can start in 100 meters, be in the air, so can use all the 500 airfields in Germany to connect point to point. At the end, this aircraft, due to very low level, 55 decibel low level, this aircraft is not for community, is not an enemy, it's a community-friendly aircraft. Nobody can claim about noise, 55 decibel, and can connect in the shortest time small communities. This is a big problem in Germany. To connect point to point, 300 kilometers is not always easy. By train, by car, we did comparison. And with such an aircraft, you can reduce the connection time between small communities. Also land inside big communities. You can land in München, in Oberschleißheim without a problem. Nobody will complain about noise. And I don't go a little quicker. And what makes an aircraft community friendly? Of course, low noise level, Steep climbing is important, and in this way we have no social and political opposition. And I show here some data sheets. This aircraft is a 3.5 tons aircraft with a payload of 800 kilograms, 10 passengers, have big doors. You can combine cargo with passengers, and has a range of 300 kilometers. And now we come to the point of range. If I see some other aircraft, electric, pure, promising about 900 kilometer range, I don't believe. With the actual technology, with a good aircraft, with a glide ratio about 20 in the working point, we can reach 300 kilometers. That is the edge. With the existing new technology, we can hope and we'll get 500 kilometers, but not more. The end point of pure electric aircraft is 500 kilometers in the next 10 years. If we want more, we now need to go to hybrid or hydrogen. But in any case, it's not possible to see, excuse me, if I see this by aircraft 900 kilometers, I don't believe this. So let's stay on the ground with our optimismus. 500, and here you have a pattern. We compare our noise level. You have a white point in the middle. It's after 2 kilometers, we have 55 decibel. We are, in comparison with Airbus aircraft, much less, it's less noisy. And you see here the ICAO definition of the noise level. And we did together with Helix and Aachen University, we did some calculation of noise level, only 55 decibel, because this is one of the most important things if you want to remain community friendly. And start in just 100 meters. Here we did some studies with computer for high-end aerodynamics, dynamical, to define the propeller traction. We have a special lift system, and in this way we can, using not only propeller, all the effect on the wing and flaps, reduce the starting distance. We did a lot of calculation for operation costs, and I don't want to go in details too much, but we can go down with prices about 65 cents per passenger per kilometer. That is very important, operation cost. And ticket price, which also are reasonable. We did some comparison between eVTOL and eSTOL. We are an eSTOL aircraft, but very close to VTOL. The main advantage of eSTOL is that you reduce the technology risk. We have in this moment regulation. We can certify this aircraft using existing regulation. Another point, this aircraft will be equipped also with the autopilot, which is the heart of the aircraft, because we have, anyway, electric aircraft is a digital aircraft. The extension to a completely digital and autopilot aircraft is much easier to be done. And we want to equip this with an automatic landing in emergency cases. And here some distance, some island hopping will be a good opportunity. Regional mobility in the 300 kilometer range and some other special application. You see here a map of all the airfields in Germany you can connect, and this is the future of regional mobility. We defined a concept using hubs and sub-hubs. In a hub you have the infrastructure needed, and in a sub-hub you can land and start in a quick time. And this concept can be integrated with general or with e-mobility in the air, with charging station at the airfield and electric car system. You see here a picture of a We did some studies here for different connection with the price of tickets, and for range about shortly under 300 kilometers, we are at about 160 euro per ticket price, which is very comfortable. This aircraft can be used in a mixed configuration, passenger and cargo, or only cargo. You see here a picture of cargo. And now we speak about extension of this aircraft in the future. We have a project E20. This can be used for hybrid because electric, as I told, 300 kilometers now, 500 kilometers in 10 years, but more I don't see. The energy density of hydrogen will not be achieved by battery in the next 20 years. So higher range means hybrid. Now, if you give me another 3 minutes for video presentation. Can you play it, please? No, not on. Elektra One in Flug. This aircraft is practically an optionally piloted aircraft. Can start and land alone. The pilot, you see here, is not moving anything. We use this aircraft for 3D mappings, high resolution, up to under 5 centimeters. This is the unmanned version, Elektra Solar. We flew with this 10-kilometer altitude. It was planned to have 20, but due to Corona, we didn't have the opportunity to fly. These were some flights in China. This goes in direction 10 kilometers altitude. That is 10 kilometers. Landing with a parachute to reduce. This is a project in Switzerland, in Solar Strato. Jumping. Now Scylax E10 is an animation. This aircraft has one pilot, small door, and 2 cargo doors. So each door used for 4 passengers. So you can enter, get out in a few minutes. Another project from us, unmanned, you can see in hall A2, is Elektra VTOL. What is special? We get quite close to 3 hours of flight with this. It's a very high aerodynamic. We use it for missions. It's flying completely by computer. You can see we have 2 aircraft here presented. Now transition and landing vertically, also with strong wind. This is Elektra Trainer. €60 operation cost per hour. Very large cabin, 1.2 meters wide, accommodating 2-meter pilots. This was a rollout we did in the German museum 1 month before. And this also full digital platform. So all A7 is Elektra Trainer, in foyer Elektra One, and A2 the Elektra VTOL. Thank you very much.
Thank you, Calin Gologan, CEO and founder of Elektra Solar, for these interesting insights in the presence and future of electric flight. Thank you very much.